All right, so this is your time. Okay, so what questions do you guys have for me? Bueller?
Very quick one.
Okay, quick one.
So back to chapter 9 with
Chapter 9?
Yeah, correlation and scatter plots.
Okay.
So we make the scatter plot first.
Scatter plot should always be done first.
If it's not linear, then we don't have to do the correlation. I just forgot that one thing.
So if it's not linear, you don't have to do the correlation. So more than likely, I would do it anyway. But you would just realize that you couldn't place strong conclusions on your correlation coefficient because it doesn't look linear.
Okay.
Yes. Not on purpose, but on accident. Okay. Yes. Now, having said that, did we watch the video on the gun control and the Freakonomics? Remember, we had the pie graph. They gave us the R² value, and we back calculated what the R values were. Remember that the strongest correlation in that case was like 0.7, I think, right? Or maybe it wasn't that high. No, it was more like 0.5, I think it was, which we would normally call moderate, but that was the strongest correlation. So that wasn't you wouldn't call that a super strong correlation. So a lot of times we will calculate that anyway. And having said that, the idea here, this might be something that we would call a moderate correlation. The bigger problem is if we're seeing something that looks like that's very curvy, okay? Then we're going to say, oh, I probably don't want to do a straight line correlation there, okay? But if you see something like this, you probably still would do a correlation, even though it's probably weaker than something like that. The idea is you're looking for curved patterns or something like that, okay? What other questions do you have? Morgan.
I don't understand the relevance of chapter 10. Like, what is that?
What was chapter 10?
The ordinary least squares.
The ordinary least squares. You don't understand the relevance, okay? It's actually, so the idea here, you understand the idea behind the scatter plot, okay? So the idea here is with ordinary least squares, there's a lot of different lines that I could draw. Even in this case, I could draw a line maybe like this, right? Which line is the best? Okay, and so what I'm telling you, the line that's the best is the ordinary least squares line, okay? The ordinary least squares line, let's say it's the blue line in this case, that's the best one, okay? It's going to give you an equation y equals mx plus b, okay? And so it's highly relevant, okay? It's the best line, and you're going to be able to use that line for prediction, okay? And so you could, depending on what you're measuring, maybe you've got some gaps in data. I will tell you this. So I was working on a brain injury study. I think you guys probably, I've said that several times. But one of the things that they had to do was they had to figure out what was called a FIM score, Functional Independence Measure, I think is what it stood for. And the idea was, the nurse went into the patient, I think they were supposed to do it every week, and they were supposed to fill out a survey. Can the patient go to the bathroom by themselves? Do they need assistance with going to the bathroom, or can they walk by themselves? Can they swallow? A lot of people, when they had brain injuries, they had difficulty swallowing. Can they swallow? How's their speech? So they would do all of these different measures. They called them FIM scores. Well, the problem was nurses get busy. They might go 2 or 3 weeks and they might just forget to do this. So you started with, say, a FIM score of a 7. You missed a couple things, then you had a FIM score of a 5. Well, we wanted to fill in those gaps in the data. And so what we would do is we would figure out a regression and would say, well, if they followed all the other patients, maybe this was a 6.6, and this was a 6.2, and this was a 5.7, or something like that. And so we wanted to try to fill in those gaps because we didn't have those, and so we would use the ordinary least squares regression line to fill in those gaps. Okay, yes?
Could you maybe do like an example of that, like us finding what?
Sure.
By hand.
By hand, okay. So when I mean by hand, that means by computer by hand, but yes.
But we won't do it on the third day, in class.
That's a lot of work. The test would take, that would be, I'd put one question on the test and you'd do it. So probably not, that's probably more likely a computer question, but we can do it by hand on the computer. That's fine, that's a good thing. Now, the problem for me is coming up with data. So there's two things I can do. We could either figure out, like, I've already done shoe size and height. I don't want to ask your weight or you'll probably get mad at me. I don't want to ask test scores. That would probably be a FERPA violation. So where's my stupid Excel here? Or I can just come up with a bunch of random numbers. Now, the funny thing is sometimes the random numbers have a bigger correlation than you would expect. So what would you like to do? Number of siblings and test score. No, just kidding. Number of siblings and eye color isn't a number, so that's not going to work. Age and number of siblings. Would you guys like to do that? We don't have anybody that's as old as me in here, so you're probably okay. All right, so we're going to see if there is a correlation between age and number of siblings. Okay, what do you guys think? There could be a correlation on that. I don't know. That's going to be interesting. So Jordan, we'll start off with you.
25 and 4 siblings.
4. Okay, and Aaron, I'm going to really work on names today. 18 and 10 siblings? Are you kidding? Okay, whoa, man. Okay. She became the outlier right off the bat. Jordan.
21 and
3. Elizabeth.
21
2.
and
Don't tell me. Greg.
Yeah, you got it. 22 and 1.
22 and 1. Morgan. 18 and 3. I do think that you are going to end up being the outlier here. We'll talk about how to deal with that. Actually, that's a good one. Melina. 36 and 3. Ashley. 23 and 3. Laura. 20 and 4. Sydney. 20 and 4. Hannah. 22 and 5. Amanda. 21 and 3. Ben. 23 and 5. Steve. 23 and 3. Alex. 5. I'm having a hard time with this one. You're gonna have to tell me. John. I should have known that. 23 and 0. Okay. Emily.
25
And 1. Gabrielle. Is it Gabriella?
Yeah, Gabrielle.
Gabrielle. 24.
20 and 4.
20 and 4. Sarah?
19 and
Amanda? No. Kimberly.
22 and
1. Penzi. 26 and what? 0. Sarah. McKenna.
19 and 3.
Caleb. 4. And Seth,
19 and 4.
19 and 4. Did I mishear you, Caleb? Oh, good. Okay. All right. So first step is what? Well, no. Nope. Nope. Scatterplot. Scatterplot's the first step. Okay. Always remember, scatterplot should be your first step. Okay. And how do we do that? You should tell me. Highlight your data. Insert scatterplot, right? Pick the first one. Oh my gosh. Hold it down. Oh, am I not sharing? I'm not sharing. When that got recorded, but it got recorded, I think. I am recording, right? Yeah. Let me make sure I'm recording. Yeah, I am recording. Okay, share. So anyway, nobody at home got to see all, we enter all that data. But anyway, okay, so highlight your data, insert scatterplot, boom. What do you think? Okay, what's the most noticeable things about this scatterplot? 2 outliers, right? Not only do we have, oh, Melina's the outlier. Okay, so sorry we gave away range. And Aaron is the outlier here. Okay, now we're going to do this. We're going to keep the outliers in, but remember, what do they say about outliers? Do you guys remember? Outliers, especially with regards to correlation. They're highly, so these would be highly influential points. So the one thing about this is Melina and Aaron might cancel each other out. If I ignore those 2 points, I'd probably say that there's a negative correlation, right? Okay. So that means as you get older, you have fewer siblings. Is that because they're all dying off? I think you might want to speculate why that would be. Yes.
Sorry, real quick, how do you tell like the shape between the negative and the positive?
That's a great question. How do you tell the negative and the positive? Yeah, this way here is negative, this way here is positive. I'm probably going to get that on video. Okay. So actually, let's talk about this graph. This graph's on video. Is this positive or negative?
Positive.
This is positive. And if I did something like this, this would be negative. Okay. Now, the question is, because we have Aaron and Melina as outliers here, that could change it, especially because Aaron is such an influential point, it could change that to be a positive correlation. That would be huge. In fact, in that case, I think it's pretty easy to see that those are outliers. We probably should remove them, but I'm going to keep them in for now, and then we'll remove them and see what it does. Yes?
So when you're doing this on the test, I would look at that and say there's like no correlation, so let it go on. Would that be wrong?
Well, I wouldn't say that there's no correlation because it does look, so if I were doing this in real life, I'd probably remove both of those key things, and I would say there's I would probably say a moderate correlation, negative correlation. Okay? All right. But we're going to leave it in there now. Now, by the way, is my graph complete? No, because it has no titles. How do I add titles? What? Click on the plus sign. Access titles. What is this? Age in years. Make sure you put your units on here. That's important. And this is number of siblings. And this is what? Math 1040 class. Okay. All right. So eyeballing that, if we take out Aaron and Melina, we'd probably say that's probably negatively correlated, right? Okay. Now we're going to get to Gabrielle's real question. How do we figure out the correlation by hand? I'm gonna make this a little bit smaller. Can I, is that still okay to see? Okay. So this is our raw data. How do we find the correlation by hand? What is the equation? By the way, I will give you the equation. I will give you the formula sheet. You guys look it up if you don't remember, but does anybody remember it? R equals sum of xi minus x bar divided by s sub x times yi minus y bar over s sub y. All over n minus 1. Okay? All right, so I will give you that. Okay? Very small to see on the board, but that's all right. You can look it up. Okay? Now, what's the first step that I need to do? Find means and standard deviations. Okay? So we're assuming, so by the way, what's the independent and the dependent variable? According to the way we've drawn it here. Age would be the independent variable. This would be the dependent variable. Okay, the dependence on the y, the independence on the x. So we're saying here that age somehow determines how many siblings you have. Does that seem like a reasonable conclusion? No. But there's apparently some sort of a relationship here. Older people have fewer siblings. That doesn't make sense. But it could also, well, it could be, we'll see. All right, so the means. What's the command for the mean? Equals average of this. Copy it. So the mean age in this class is 22.1. The mean number of siblings is 3.29. Okay. How do I find the standard deviation? Can you do that by hand? Did we do that on this test or last test? Oh, it's going to be on this test. Okay, well, we'll do that in a minute. We're going to use the cheater method for this. What command can I use? SCDEV. Which one? These are both samples, right? Yeah, the S. Because it's a sample. You were testing me. Because I won. That's good. All right. So the standard deviation is 3.68 years and 2.05 siblings. That seems like a very high standard deviation when it's all because of her. Okay? Yes?
Are they mostly going to all be samples on them?
Most of the time you're going to use samples. Yes. Okay? All right. So we found the means. That was step number 1. Found the standard deviation. Step number 2, Sydney.
So if this was a test question, would you be able to find the standard deviation like that?
For the regression, yes, you can.
Okay.
For the standard deviation by hand, no. Okay, good.
How do we know if it's not?
How do we know if it's not a sample? It would be a population. So there would have to be something to give it away that there was a population. Okay? Was there another question? Yes. You're good. Okay. What's the, so, okay, so looking at my equation, I found the means, I found the standard deviations. What's the next step?
The standard deviation scores?
We need the standard scores. Standard scores for the age and the standard scores for the siblings. I'll just put number because that's shorter. Okay? All right, so how do I do such a thing? Equals, so you need to include parentheses on here. Parentheses, what did you say, Elizabeth?
So the age is 25.
Click on the 25. Minus the mean, which is
Down there.
22.1.
F4 that.
F4, the second one. Okay, so we want that not to change. Close my parenthesis and then divide by standard deviation, which is 3.68.
And then F4 that.
F4 that one. Okay, so 2 out of the 3s are F4. Only the first number is not. Because we want that first number to change. We want the last 2 numbers not to change. Okay? So I can copy that down, double click on the corner, okay? Now, who can help me with the standard scores for the number? Somebody besides Elizabeth. Morgan.
4
4
minus
minus
3.29.
2.29.
F4.
F4, very good.
Close
Close
parentheses.
parenthesis,
Divided by
divided by
the one below that.
2.05.
F4.
F4, that one. Okay. We're going to copy that one down. Okay. Now what? Okay, so we found the means. We found the standard deviations. We've now found the standard score for the x. We found the standard score of the y. What are we doing next? We're going to multiply them together. So I need the product here. Okay, what am I multiplying? 0.77 times 0.34. Do I need to F4 those?
No.
No, do not. Okay, I'm going to copy that down. Oh, now this is interesting. By the way, did you see that? I think I told you you should always leave a space because then it does stupid things like this. Okay? It's because I put dependent and independent there, but okay. All right, now what? What's the next step?
Divide by 23.
No,
Oh, wait,
do the
add
sum. We do the sum. The sum of what?
product.
Of the products, which is this column here. If I add that column up, I get negative 6.98. So that is still negative, even with Aaron trying to force it positive, it's still negative. Okay? And is that okay? So my n is, if I highlight this, I've got 24, so I'm going to divide by 23. So divide by n minus 1, which is 23, divided by 23. And so that gives us negative 0.303. So what would we say? That's right on the borderline, right? Is that strong, moderate, or weak? Yeah, it's right on the borderline of moderate to weak, right? Okay, so we'd say that there's not really a very strong correlation. Now, the next question is, we think that Melina and Aaron are outliers. Okay, let's see how that changes things. So what should we do? By the way, do you guys remember how to find outliers? Is that on this test? What'd you say? The IQR and all that. We should probably verify that those are outliers before we remove them. Okay, how would we verify those are outliers? By looking at them. Okay, but what if, you know, sometimes they might not be? How can we prove that they're outliers? What'd you say? The 5-number summary. Let's do the 5-number summary for the age and the number of siblings. Okay, so the 5-number summary consists of minimum, Q1, median, Q3, max. Okay, how do we do that? How do we do it for the age? Equals what?
Min of all that.
Minimum, yeah. Oh, you guys just said, oh, I know it's 18. But it probably is 18. Okay, how do we define the maximum? Max. Okay, Q1, how do we find that? Yes.
Would it be a mistake at this point to order the data?
Would it be a mistake? That's a really good question. I would leave it alone because here's the problem. I'm gonna sort this data sort A to Z. I'm gonna continue with the current selection. Watch what happens to my graph when I do this. And now let me sort this one. Data, sort, continue with the current selection. Ooh, I just made that very linear. Is that linear? Should it be linear?
No.
No, it should not be. And in fact, I just went from moderate to weak to super strong. And positive. It went from negative to positive. Okay? Really bad idea. So here's what I would say. Well, I'm going to undo that. I'm going to undo that. Okay? So if you want to sort them, and you're more than welcome to, leave the data as they are, make a copy of them, paste the data here, then you can sort this and do whatever you want to it. Okay? But here's the problem, okay? Because this 25 should be associated with that 4. In fact, I'm going to see if I can highlight these. If I sort the age by itself, data, sort, continue with the current selection. Oh, you know what? I'm going to do that one more time. I didn't include the title in there. Sort, continue. That 25 just went down to the 0. It's now associated with the wrong. Now, that was you, right? You're 25?
Yeah.
So we just changed you from 4 siblings. Now you're an only child.
Yeah.
Okay? Now, if we do this here with the siblings again, continue that 4, this is Jordan's now 4. Jordan's 4 got associated with one of you 22-year-olds. Okay? And maybe you do have 4, I don't know. But at any rate, so you got to be careful with that kind of stuff. All right. How do I find the quartile? The Q1 equals quartile. Which one? The bottom one's the best one. Okay, the bottom one and the included are the same. Okay, I can highlight this, comma, 1. Okay, now the easiest way to do this is to simply copy and paste this twice. Okay, now I'm going to change this to a 2 and this to a 3. Okay, and then, yeah. Okay, I could have also F4'd that. The way I copied it, I was okay. Now the cool thing, the way I copied it is I could slide this over and it will find all that for me. Isn't that cool? Okay. All right, so review, how do we find outliers? I did. I did do that. You need to be careful with that. But yes, the way I copied it, I was okay. If you do it, you might do it wrong. Okay. Now the reason why is because these are all A2 to A25. So check your range on these. All these should have the same range. A2 to A25, all of those do. Okay. Because they all have the same range, even though they're different commands. Okay. I can now highlight those. If I click on the little square here, it goes into a black cross, drag it over. Now these are all the B's, B2 to B25. Okay? Or do them manually, that's probably the safer way to do it. Okay? Yeah. Yeah, so get there early if it takes you a long time to do this. All right, so now how do we find, what's the next step? Find the IQR. Whoops, IQR. And the IQR in this case is, nope, it's not 18. It's Q3, which in this case is 23 minus 20, right? Which is 3. So the interquartile range, and I can copy that over. So 3 years is the interquartile range here. 1.25 is the siblings here. I can definitely tell those are going to be outliers, right? Now, what's the next step? 1.5 times the IQR. So I'm going to take this times 1.5. So now it's 4.5. We might have more than just, no, maybe not. We'll see. Well, Lena, you might have somebody else that'll join you as an outlier. We'll find out. Okay. So now what? You need to do the lower fence and the upper. The lower fence is Q1 minus 4.5. Do we have any 15-year-olds in the class? No, so we're okay there. The upper fence is Q3 plus 1.5 times 27.5. Okay. Now this is where I will say to point out to Greg here. Okay, I'm gonna highlight those. This is where definitely is going to come in handy to sort these. So if you're going to do this, just make them separate. Sort smallest to largest, continue with the current selection, and do the same thing here. Sort smallest to largest, continue with the current selection. Okay, so 27.5 is our upper fence. Ooh, so the 26-year-old, you almost became an outlier. You almost joined, but now it's just Melina, okay? And number of siblings. So now we can copy this over too. So 0.875. Oh, we have some outliers here that we hadn't considered earlier. Those zeros are outliers, right? Okay. The ones are not. And the 5.875. Okay, so yeah, we kind of suspected that Erin would be the outlier there, and she was. Okay, but we didn't, so here's two that we didn't suspect that are. Okay, so if we're going to do this properly and remove all of our outliers, we need to remove actually, and so when I say remove, is it okay for me to simply go, oh, that 23-year-old, is that okay? No. We need to remove that whole line. Your whole line is now an outlier. Okay, where's the other zero? This 26-year-old, you're an outlier. We're removing you completely. 10, we knew you were the outlier. And 36, we knew you were the outlier. Okay. Now look at my chart. So my chart got updated there. Okay. Now the problem is we divided this by what? 23, but now we should divide it by 20, which is 19. So we're going to divide by now, instead of 23, we're going to divide that by 19. Now what do we say? It's actually very weak. In fact, well, that still looks like a downward trend to me, but yeah, it's not, it's a very weak correlation between age and siblings, which actually kind of makes sense, right? Why would there be any sort of correlation? So you guys were screwing us all up. Yes?
Please just go through whatever problem you want to make the test. Just make sure it's not going to be like.
You want me to write the answer key before the test? Oh
Just
boy.
when you know that, I mean, you've done it before on homework or something, it ended up being, yeah, a little bit more complicated than.
I would try, but yeah, I no guarantees, but I would try. Okay. All right. So now we decided that was weak. It's even weaker without the outlier. So that's kind of interesting. Yes.
So it's like taking out the outliers requires something that will have to do with
Was that in chapter 7 through 12?
No.
No? So here's what I would
We
say.
already tested on that last time.
Yeah, you guys did horrible on it. I probably should throw it back on.
No, I did.
We did do horrible on that. Remember? Everybody did terrible. I would, you know what? I wouldn't mind putting that back on there just to give you guys a reprieve and see if you can do it. Okay?
We already failed it on the first one.
Yeah, so you need to learn from your mistakes. That's what that means. Okay?
But I didn't get mine.
So the answer is, you know what? I think I'm going to put that on there. Okay? It would be good. Who asked this question? Okay? We're going to find out if you learned from your mistakes. And by the way, I haven't graded any of your test corrections. I'm going to do that during your test. Okay? That's what I'm planning on doing it. So when you see me on the computer, that's what I'm doing. All right. So we decided this is now weak because we got rid of all these outliers. Okay?
Even though you're gonna put that on the test, like, we're gonna have to get rid of the outliers.
Get rid of the outliers. Yeah. Okay? So you can watch this again. This will be the most watched video, right? You guys have ever done. I think so. So it's going to be one question with like n parts.
So are we gonna have one question on the test then?
No, because you got to do the other stuff too. Yes.
So you would want to know like the correlation coefficient and all that, when you went back and found the outliers, this, would you do that, show all?
Yeah, you
of
probably
them
should
for
find
it?
the outliers first.
Okay. That's what I'm-
Yeah.
Your work, you go back and fix it. and show
Yeah, you probably wouldn't want to fix that after the fact. Yeah, you should find the outliers first. Yeah. Okay. Was there another question? Yes.
Can you spell like the range from strong, moderate, and?
Yeah, what was the range for strong, moderate, and weak? You guys remember?
Anything on the.
Strong was
Correlation is greater than 0.7.
absolute value is greater than 0.7 is strong.
Between
0.3 to 0.7 is moderate. Less than 0.3 weak. The closer you get to 0, that would be no correlation. Okay? All right, now here's a good, I got two really good follow-up questions. Okay? If we haven't done a standard deviation by hand, I can pick either one of those to do by hand. You guys have a preference there? So that's one question. The other question is, find the ordinary least squares regression equation, even though it's a bad model. It's still good. It's still good for proving your math. Which one would you like to do first? What? Ordinary least squares. You want to do that one first? Okay. So the next question is find OLS equation by hand. Okay. What are the big important equations that I need to know? Say it again. Okay, so eventually I'm going to need y equals mx plus b, which means I need to find the m and I need to find the b, right? What's the m? It's the slope, and what's the equation? S of x, okay. And b is
Y bar minus mx bar.
minus m times x bar. Y bar minus m times x bar. Okay, so now we've actually found our r already, right? So my m in this case is going to be what? Negative 0.112 times s sub y. What's s sub y?
That's the standard deviation of.
Standard deviation of y, which in this case is 1.26 divided by standard deviation of x, which is 2.01. So you can see how important finding that is. Okay? All right, so my slope is negative 0.07. My b is the mean of the y, which is 3.3, minus m, which is right above it, times 21.4 years. Okay? By the way, I think we went from 22 to 21.4, right? So, all right. So what's my y equals equation going to be? Negative 0.07031. Oh, I forgot the decimal, thank you. X plus 4.80469. Okay. All right. So is this a good model? Jordan's saying no. No, because
do you mean when you ask that?
What do I mean when I ask that? Jordan just got lucky.
It's 50-50.
So when I ask you if it's a good model, you need to say yes or no because, and then give a reason. What would be the reason? Well, so we could base it on the correlation. There's even a better way to do it though. Correlation was weak. It's negative 0.11, right? Is there, what else could we use to figure out if it's a good model? Correlation squared. So the R squared in this case equals negative 0.11 squared, right? So that's the answer to the no because. No because the model explains just %1 of the variation. How did they get 1%? From the R squared value. Okay.
And I know that she asked.
So 1% of the.
We never really got an answer, but can we just say roughly 50% and higher is good, or no?
For the R squared.
Oh, I
You
didn't
went
understand what you were
through your
saying
video
there.
last time to answer that question, and it turned out that was a bad example, so. Like this one is clearly 1%.
It's clearly
like you-
terrible.
You get that, and if it was 90, then obviously it'd be good.
Yeah.
But what about 60?
I would say you generally would like your R squared ideally to be above. I mean, the problem is you can't get, ideally you'd probably like it to be above 0.7 or 70%. Now, having said that, what do you guys remember from the Freakonomics video, what their R squared value, and they were using a lot more variables than just one. It was, yeah, it was like 55% was explained, 45% was unexplained, and so therefore, well, I don't think we watched it, but they were saying, well, abortion explains why that, which I don't know if I would agree with that, but at any rate, okay. So that was the model that they got. They only got 50%, 45% unexplained. So yeah, but you guys are doing much more simple models than they're doing. So I would say, yeah, ideally you'd like to have it 70% or better.
So if you had your question on the test and it was like 56% and you say no because it's 56%.
So it would be a good model. It would be an okay, I would call that an okay model. Just 56% is explained, 44% is not explained. Yeah, yes, no, okay.
What about perhaps?
Perhaps. I'd take perhaps. Okay? Okay? All right. What? Oh, so now, okay, so we're done with that. So we've done that. Do you guys know how to find it the super easy way?
Oh yeah, with the little dot.
Find the dot. You can click on this. So you can know if you're right or wrong. How many points are you going to get for this? 0, but you can still do it. So you can add your trend line. You can display your equation and your R squared. You can know immediately if you got that right. I'll let you do that. You can check yourself, but you'll get more points if you go through these steps wrong than if you say, oh, my R squared is 0.126. Okay. All right. All right. So the last thing, do you guys want to do age, standard deviation of age or siblings? Age. Okay, so we're going to take out our outliers. I'm going to just do this on here. So this is standard deviation by hand. Okay? And this is correlation and OLS and outliers. Okay? All right, now we're doing standard deviation by hand. I just copied it. How do we do this by hand? What's the equation? Really need to put a line eraser here. I have to set myself an alarm so I remember. What's the equation for standard deviation? Is this S or is it sigma? S. How do you know? Because it's a sample. S for sample, sigma for population. Okay? S equals the sum. I don't think that I'm gonna, data minus mean is correct, but I don't think that's what I'm gonna give you for the formula. Xi minus what? X bar. R of X. Oh, like R of X, what? Squared. Divided by.
Either n or n minus 1.
This one's gonna be n minus 1, the whole thing is gonna be square rooted, right? Okay. All right, so what's the first thing I need to find? Mean, okay? And the mean in this case is, I'll let you use the average command and then say curse Bill Gates when you do it, okay? 21.4. Okay, now I'm going to do data minus the mean. So who's struggling with this, wants to do well on the test? Morgan, I pick on you way too much. Okay.
3.6.
Well, tell me what to click on.
25.
25 minus 21.4.
That one you wanna.
Yeah.
For the second one, right? Okay. Now the problem is I got all these gaps in here, right? So you know what you might want to do before you do that is get rid of the gaps. This is how you cut and paste all in one step. Or you could have sorted it, I don't care. All right, so now we're good. Okay, now what? Square the difference. So take that, and how do I square it? Caret, which is shift 6 to the second power. Do I need to F for that? No. Okay. Then what? And the sum. What's the easiest way to do that? Click the auto sum button right there. Okay. By n minus 1. My n in this case is 20, so I'm going to divide by 19. And that's what? That has a special name. That step. Variance, very good. And the standard deviation is square root of that 2.01. Does that seem like a reasonable number? 2 years? Yeah, that seems pretty reasonable. Okay. Is there a way to check that so you know if you got it right? How many points are you going to get? 0. But you can check it and know if you're right immediately. Which one? The dot S. And just highlight your data, and hopefully we'll get 2.01. Bingo. Booyah. Ace the test. Okay? All right. How you doing, Alex? You gonna ace my test? Are you gonna ace my test? Okay, you better. Okay, what else you got? We got 10 minutes. Should we look at the things here? Okay.
On chapter 7, when we did, simulations.
Oh, simulations, that's a good one.
There
Okay.
was a homework question that was like 90% are in favor of abolishing exams to the 10 students.
Which homework question was this?
It was number 1.
So chapter what again?
7.
Chapter 7, homework 7.
I was just wondering how, you got the probability that all 10 favor abolishing. Like I get that it's like 90% raised to the 10th power, but I don't get how we got
Okay. Which one was it again?
number 1.
Number 1. Suppose 90% of university students in favor of abolishing evening exams. You ask 10 students at random. What is the probability that all 10 favor abolishing the exam? And you said that's just simply 10. No, it's what? 0.9 to the 10th power. And you're asking, how did I get that? Are you asking how I got that? Okay, so the easiest way to explain that is, I think I'll just do this one on the board. Okay. Okay, so I've got 10 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. What's the probability that the first person wants to abolish the exams? 0.9, right? What's the probability of the second person? Also 0.9, etc. All the way to in here. So I'm going to have 10 of those, right? So I'm just going to multiply those all together. So 0.9 times 0.9, I'm going to do it 10 times. So that's why it's raised to the 10th power. Okay, does that make sense? Now we're assuming, maybe a little bit unfairly, although we said it was a random sample, right? We're assuming that these are all independent. Now, if I went and I said, Jordan, do you favor abolishing the exam?
Oh, yeah.
Yes. So then I go to Elizabeth, she might feel pressure to agree with Jordan, right? So, so you could argue that her answer, if I specify as doing this publicly, her answer might be influenced by his answer, especially once we ask 8 people and they all want to abolish the exam. That's going to put more pressure on the young people. Okay. So when you're doing such a thing, you probably that's another reason why you should do it anonymously, so that you don't want to be like, oh, I'm the only person that wants to keep exams. Okay. Does that make sense? So we're assuming it was a simple random sample. They weren't, because you could argue that if I did it publicly, it would not be independent. It would be dependent, especially towards the end. Okay. Yes.
So for example, if this question said that you asked 10 or 20 students at random, it would be 0.9 to the 20.
Yes, 0.9 to the 20. That would be correct.
Why is it not just 90%? Like when you ask 10 students, why is it not just most likely 9 out of 10 of them? Why is it different?
Okay, so you're asking why would it be different? Okay. The answer to that question, we talk about that a little bit more in my Math 2040 class. But let's think about what's your sample space, okay? I'll try to explain it this way. This actually gets into what we call a binomial distribution, okay? So the idea here is, if I ask 10 people, do you favor abolishing exams? What are all the possible number of responses that I could get? What's my sample space? So if I've got 10 people, how many people could say, yes, abolish exams? 10, what's another option? 9, 0, okay? So I could get anywhere 0, 1, 2, 3, 4, all the way up to 10, right? Okay, this is actually a little bit of an advanced question for this class, but I want to explain this to you. Okay, so the probability that I got nobody that wants to abolish exams. Okay, so the probability the first person does not want to abolish the exam would be 0.1, right? So the probability of X. Okay, so this is going to be 0.1 raised to the 10th power. Do you see that? Okay, now on the other end of the spectrum, okay, 1 times 10 to the minus 10th. That's a pretty small number. On the other end of the spectrum, I'm going to have 0.9 to the 10th, okay, which is 0.34. So there's only a 34% chance that all 10 of those are going to say yes, abolishing exams. Now, let's talk about 9 people want to abolish exams, 1 doesn't. Okay? So one way to think about that, if I'm going back to here, let's say the first person does not want to abolish the exam, but everybody else does. Okay? Or another option would be the second person doesn't want to abolish exams, but all the others do. So basically, I can move this away, move this to every location until the last person doesn't want to abolish the exams. So how many ways are there to do this? Yeah, basically, I can move this into any of the 10 slots, right? So there's 10 ways that I can do this, right? Okay, let me put it here, 10 ways. Now, if I do this the first time, it's going to be 0.1 times 0.9 to the 9th. Does that make sense? Because 9 people want to abolish exams, 1 doesn't. Okay? So the probability that I get exactly 9 people that want to abolish exams is going to be basically this times that, which works out to be about 0.38. So that's slightly more probable. Now, we're out of time, but let me just say this. There's a really cool command called binomdist that will answer all these for you. So the number of successes, I'm going to say 8, number of trials 10, probability of success 0.9, and faults, I'm not going to explain this to you, but what I'm trying to say here, if I do this for everybody, I could actually create a histogram. Oh, that didn't work because I forgot that these have to be apostrophes. By the way, remember, if you want these to be labels, you got to make those apostrophes. But insert histogram, make it touch. Okay, so that's the distribution. And by the way, if this is a real probability distribution, what should it add up to? 1 or 100%. And it did, it adds up right. Okay, so the probability I get exactly 9 would be 38%. 10 out of all 10 would be 34. It gets smaller, it gets ridiculously small down here at the other end, because 90% of the class wants to abolish exams.
So it's not
Okay.
just the probability, it's like the probability that they match the probability.
So the problem, yeah, because the problem is, if I did one example here, the first person could say no and the rest of them say yes. And the second person could say no. There's 10 ways to do this, okay? And so the probability that I get exactly 9 is actually just 38% of the time I'll get exactly 9. Okay? But that's kind of an advanced question. All right. So remember, you can start taking the test tomorrow if you want it to be free in the testing center. Thursday in class, we will have a written test right here. You can leave when you're done. If you want to take it Friday, they close early, get there early. Remember also, there could be a big line, especially if you wait till Friday, because there will always be a line and then you're going to have less time. So I would recommend don't take it Friday, but if you have to, you have to. Okay, see you all Thursday.
So you said the